Hello everyone. Today I'm here with you all with one of the topic of class 8 maths curriculum, that is Introduction to Graphs. In this video we will be learning what is line graph, how we can represent the given data using your line graph, how we can read it and how we can get the information by the line graph. So let's start with the topic, that is your Introduction to Graphs. So first of all, let's understand what are graphs. Graphs are the visual representation of data collected so that they can be understood quickly, easily and clearly. In the video, that is your data handling, we have learned that what is data and how we can represent the given data in the form of tables and in the form of your graphical representation like your bar graph, double bar graph and the pie chart. So here in this video, we will be learning how we can represent the data using your line graphs. So whenever we are representing any of the data graphically, so we can understand it very quickly, very easily and very clearly. So let's understand what is your line graph. A line graph displays data that changes continuously over periods of time. So whenever we are having a data which is changing continuously with the period of time, we can represent such type of data using your line graph. Now let's understand how we can represent the data using your line graph. Suppose there is a data which shows a number of days a hillside city received your snow in different years. In the year 2003, 2004, 2005 and 2006, these are the years we have taken. In the year 2003, number of days was your 8. In the year 2004, it was 10. In the year 2005, it was 5. And in the year 2006, it is your 12. Now, this is the data which is given to us in the form of your table. We have to represent it graphically, that is using your line graph. So, what we will be doing is, first of all, we will be making the perpendicular lines. This is your horizontal line, this is your vertical line. This horizontal line is known as your x-axis, this vertical line is known as your y-axis. The point where these two lines are intersecting is the origin, denoted by your O. Now the two information we are having, one is your year, another is your days. So we will be taking years on the x-axis and number of days we will be taking on the y-axis. So here we will be taking your years. This is your 2003. This is your 2004. Here it is your 2005 and here it is your 2006. At the unit distance, at equal distance, we will be taking these years. This we have taken on the x-axis and on the y-axis, we will be taking number of days. This we will be mentioning over here, that number of days we are taking on the y-axis. Now it is starting from 5 and ending at your 12. So we can take an interval of like 2, we can take over here. It is your 4, it is 6, then 8, then 10, then 12, then 14. Like this we can take at uniform distance, we will be taking these numbers. Gap of 2 we have taken, and at uniform distance we will be taking all these numbers, that is showing your number of days. Now in the year 2003, number of days was your 8. So this is your 2003, number of days is your 8. So we will be moving upward where it is intersecting your line which is coming from 8. This point will be representing that in the year 2003, number of days was your 8 on which we received your snow. In the year 2004, it is number of days is your 10. So 2004 will move upwards here, and from 10 if we'll be moving, they both lines is going to intersect at this point. So this is showing that in the year 2004, number of days was your 10. In the year 2005, number of days was your 5. So 2005, number of days will be 5. That will lie in between your 4 and 6. So from here, we will be moving up. It will be your distance, your 5. This will show your 5. In between your 4 and 6, it will be your 5 for the year 2005. In the year 2006, it was your 12. So 2006 will move upward like this, and from 12 like this. So the point of intersection will be somewhere here. So this is showing that in the year 2006, number of days was your 12. First of all, we have plotted all these points. Now what we will be doing is, we will be joining these points. From 2003 to 2004, these two are the points. So we will be joining these two. Now 2004 to 2005, so we will be joining these 2 points. 2005 to 2006, so we will be joining these 2 points. So this is the line graph, and using the line graph, we can show the given information to us. Just now we have seen that how to represent the data by your line graph if any of the information is given to us. Now let's understand this using another example. If the population, that is in thousands, of men and women in a village in different years is given to us, that is in the year 2003, 2004, 2005, 2006 and 2007, what is the number of men and what is the number of women in your thousands? That means in the year 2003, number of men was your 12,000 and number of women was your 11,300. Similarly, in the year 2004, number of men was your 12.5 and number of women was your 11.9 in thousands it is. Now, if two information is given to us, in the previous example, we have taken only one information was given to us. Now here in this example, in the same year, that is 2003, number of men is even given to us and number of women is even given to us. So how we will be representing this type of information using your line graph? First of all, again, the same we will be making your x and y axis. This is your x axis. This is your y axis. On the x axis, we will be taking your years. This is your years. On the y axis, we will be taking population in thousands. Population in thousands. This we have taken on the y-axis. Now two graphs will be there, one for the number of men, another for the number of women. First of all, we are taking years on the x-axis, that is 2003. This is your 2003. This is your 2004, 2005, 2006. At uniform distance, we will be taking all these 2007. Now on this is your x-axis, this is your y-axis. Now here on the y-axis, we will be taking your population in thousands. It is starting from your 11. The lowest is your 11.3. So we can start from 11 even. So we have taken over here 11. And because it is not starting from 0, so we will be making a kink over here. Like this, we will be making a kink over here because it is not starting from the zeros. We have started it directly from 11. So we have made a kink over here. This is 11. Then 11, after 11, we are taking your 11.2. Then 11.4, 11.6, 11.8, that is your 12, 12.2, 12.4, 12.6, 12.8, we are extending it. Then it is your 13, 13.2, 13.4, 13.6. Like this, we have taken on the y-axis at a distance, the distance between two consecutive points we have taken as 0.2. That is in thousands, 0.2. That means of 200 we have taken the difference. So what we have done is on the x-axis we have taken the years. On the y-axis we have taken population in thousand. So first of all, we will be making for number of men. Number of men in the year 2003 was your 12,000. So 2003 will be moving up and 12,000 is here. So this will be the point. For the 2003, number of men is your 12,000. For the year 2004, number of men is your 12.5 thousand. So 2004, it is your 12.5. So it will lie between your 12.4 and 12.6. So we have taken moving upward from 2004 and it will be your 12.6 here. 12.5 will be here in between 12.4 and 12.6. Now in the year 2005, it is your 13,000. So 12.5. It is your 13,000. So it will be somewhere here. When we'll be making it on the graph paper, it will be accurate. But here, because we are not using the graph paper, so it is approximate the same. In the year 2006, number of men is your 13.2 thousand. So 2006 will move upward. It is your 13.2. So that will be your, this is the demarcation for your 13.2. In the year 2007, it is 13.5. So 13.5 will lie between 13.4 and 13.6. So we will be taking it like this. 13.5 will be your here. This is your 13.5. We can change the scale also. Instead of taking a difference of 0.2, we could have taken 11, then 11.5, then 12, then 12.5 also. That even we could have done. So what we will be doing is, now we will be joining all these points. So like this, we have joined these 2 points, then these 2 points, then these, and like this. We have joined all these points. Now we have made the straight lines over here. this line we have taken. So we will be denoting it that this line shows your number of men. This line is showing number of men, and we will be making another line that will be dotted line that will be showing your number of women. Both should be seen visible separately. So we have made the number of men by your straight lines like this, and number of women will be making by your dotted lines. Scale, whatsoever scale we have taken on the y-axis, scale we have taken is on the y-axis. It is your 1 unit. 1 unit is your 0.2 thousand. 1 unit, or you can say 1 centimeter is equal. It is equivalent to your 0.2 thousand, or you can say 200 even. This is the scale we have taken on the y-axis. So whatsoever the scale we have taken, that we will be mentioning. Along with that, we will be mentioning that which line shows what. Over here straight, this line shows your number of men. Another line we will be making that will be showing your number of women. Now for number of women, 2003, the population was your 11.3 thousand. So 2003, 11.3 thousand. So it will lie between 11.2 and 11.4. So it will be here. In the year 2004, it is 11.9 thousand. So 2004, it is 11.9 will be between 11.8 and your 12. So here, this is your 2004 population for women. Now for the year 2005, it is your 13,000. It is same exactly what was the population for your men. So this will be the same for the population for your men even and for women even for the year 2005, this point. Now for the year 2006, it is your 13.6. So 2006, it is your 13.6. So 13.6 is your here. This is your 13.6. And in the year 2007, it is 12.8. So 2007, it is your 12.8. So this will be your 12.8. Now again, we will be joining for the number of women, we will be joining by dotted lines. So that we can differentiate which is showing your number of men, which is showing the number of women. This 2003 and 2004 we have joined. Now 2004 to 2005 we will be joining by dotted lines like this. 2005 to 2006 will be joining by dotted lines, and 2006 to 2007 we will be joining by dotted lines. So this is how in one line graph we can show both number of men even and number of women even. So if two different are there, two different information we have to show in one graph, so we'll be making different type of lines, and this is how we can compare it very easily even. Now let's see another example. Suppose yearly sales figure for a manufacturing company is given to us. Here on the x-axis years are given to us. On the y-axis sales in crores it is given to us. In crores, unit is your in crores, it is there. So 2002, 2003, 4, 5, 6, this is your years given, and over here on the y-axis we have taken sales in crores. Now, what were the sales in 2002 and 2006? These are the questions. How we can read this graph, that we will be learning from this question. So what were the sales in the 2002 and 2006? So we can see over here 2002. So we will be start moving from upwards, 2002 like this. And the point, when we reach this point, we will be making a horizontal line like this. So it is meeting your y-axis at your 4. That means in the year 2002, it was your 2002, it is your 4 crores. Sale was of your 4 crore rupees. So in the year 2006, how much was the sale? Again, we will be moving upwards from 2006 like this. We will be moving upwards. And when we will be reaching the point, we will be making a horizontal line like this. The point where it will be intersecting your y-axis, it is coming your 9. So in the year 2006, it is your 9 crore. Now in the year, what were the sales in the year 2003? So in the year 2003, again we will be making a vertical line from 2003. When it will be touching your point, then from here we will be making a horizontal line. So it is in between your 6 and 8, that is your 7. So in the year 2003, it is your 7 crore. The next is your 2005. So in the year 2005, again we will be making a vertical line from here 2005. When it will be touching your point, Then from this point we will be making a horizontal line wheresoever it is touching your y-axis. This is your 11. So in the year 2005, it is your 2005. This is your 2005. This is your 11 crore. So this is the information we are getting from your this line graph. Now compute your difference between sales in 2002 and 2006. What is the difference between the sales in your 2002 and 2006? So from here we can see in the year 2004 sales was of 4 crore. In the year 2006 sale was of 9 crore. So what is the difference? Difference will be your 9 minus 4, that is of your 5 crore. In which year was there the greatest difference between the sales as compared to it previous year? So in which year the difference is your greatest? Now see, from 2002 to 2003, what is the difference? 2002 to 2003, difference is your from 4 crore, it changed to your 7 crore. So difference is of your 3 crores. From 2003 to 2004 we have not computed, so we will be calculating it for 2004 even. We have made the vertical line, then from here we will be making a horizontal line. So for 2004 it is your 7 crores. For 2004, just 2004, yeah, it is coming in between your not exactly in between, you can say it is somewhere like here, because 7 is here, so it will be around say 6.5. It is around approximately 6.5 crores. If we will be making a horizontal line from this point, it will be somewhere here lie between 6 and 8, not exactly in between, near to your 6 it is. So it is your 6.5 crores approximately. So difference between 2003 and 2004 sales. 2003 sales was your 7 crores, 2004 sales is your 6.5 crores. So difference is almost of your 0.5 crores. Now from 2004 to 2005, 2004 it is your 6.5, 2005 it is your 11. So it will be your 4.5 crores. Difference will be of your 4.5 crores. So this difference is your 4.5 crores. From 2005 to 2006, 2005 it is your 11 crores and 2006 it is your 9 crores. So difference is of your 2 crores. So highest difference is your 4.5. That means in the year 2005. In which year it was the difference was your highest? That is your 2005. So this is how we can read the given line graph even. This is how we can make the line graph, and this is how we can read the line graph. Now let's understand the applications of your line graph. In our day-to-day life, we come across so many situations when with the change in the one quantity, another quantity is even changing. Suppose I am saying that if I'll be purchasing 5 pens, then the amount which I am paying to the shopkeeper is your 50 rupees. If I will be purchasing 10 pens, then the amount which I am paying to the shopkeeper is 100 rupees. If I am purchasing say 15 pens, then the amount which I am paying to the shopkeeper is your 150 rupees. As the number of pens is increasing, your amount paid to the shopkeeper is even increasing. So with the change or with the increase in the one, another one is even increasing. One of the quantities is your number of pen, another quantity is the amount paid to the shopkeeper. With the increase in the one quantity, another quantity is even increasing. Similarly, we can take another example. Say if we are having 1 liter of petrol in our vehicle, then the distance traveled is your 10 kilometer. If 2 liters of petrol is there, then the distance traveled is your 20 kilometer. If 3 liters petrol is there, then distance traveled is your 30 kilometer. So as the petrol is increasing, the quantity of the petrol is increasing, in the same way your distance traveled is even increasing. So with the increase in the one quantity, another quantity is even increasing. So we will be saying that both the two quantities are in direct variation. Over here, number of pens is your independent variable. It is your independent variable because it is not depending upon anything. As per our wish, we are purchasing the number of pens. So it is your independent variable, and the cost, which is depending upon the number of pen. As the number of pen is increasing, your cost is even increasing. So cost will be your dependent variable. So this will be the dependent variable which is depending upon the number of pens, and number of pens will be your independent variable. Now let's see how we will be plotting. When we will be plotting these type of information on the graph, then what type of graph we will be getting. In these type of cases, we will be getting your linear graph. So what is your linear graph? A linear graph, a line graph which is whole unbroken line is called a linear graph. We will be seeing an example what type of linear graph it looks like. So whenever we are getting a line which is unbroken, then such type of line graph is known as your linear graph. And the situations in which two quantities are in direct variation, as we have taken these two as a situation, they are directly proportional to each other, they are in direct variation. That means as the number of pan is increasing, in the same way your cost or the we can say amount paid to the shopkeeper is even increasing. So when two quantities are in direct variation, the graph will be a linear type of graph. In these type of situations, when two quantities are in direct variation, whenever we will be plotting the graph, it will be a linear graph. Now let's take an example. Suppose we are taking the distance traveled by car. Time in hours we have taken as one of the quantity. Another quantity we have taken your distance. So at 6 a.m. distance traveled was your 40 kilometer. At 7 a.m. distance traveled was your 80 kilometer. At 8 a.m. distance traveled was your 120 kilometer. At 9 a.m. distance traveled was your 160 kilometer. So first of all, we will be making a graph like this. We have taken two perpendicular lines. This is your x-axis, this is your y-axis. On the x-axis, we are taking time in hours. Over here, we are taking time in hours. On the y-axis, we are taking your distance in kilometer. This is the y-axis and we are taking distance in kilometer. So these two axes we have taken. Now the time is your 6 a.m., 7 a.m., 8 a.m. and 9 a.m. At uniform distances, we will be taking it is your 6 a.m. The distance between the two will remain same, 7 a.m. because distance, the difference between these two is even same. 1 hour difference, 1 hour difference, 1 hour difference. So distance between these two will even remain same. It is your 8 a.m. and it is your 9 a.m. On the x-axis, we have taken time. On the y-axis, we will be taking distance traveled. This is your 0. This is your 40. Then it is your 80. Then it is your 120. It is your 160. This is the distance we have taken on the y-axis. Now, at 6 a.m., distance traveled is 40. So the point will be, from here we'll be moving upwards. So this will be the point. At 7 a.m. it is 80 kilometer. So 7 a.m. 80 kilometer will be here. At 8 a.m. it is your 120 kilometer. From here we'll be moving upwards. So this is your 120 kilometer. At 9 a.m. it is your 160 kilometer. So we'll be moving up from 9 a.m. 9 a.m. it is your 160 kilometer. So this will be the point. So when we will be joining all these points, it will make a straight line. It will be a straight line. When we will be using ruler, it will be making on the graph, it will be exactly a straight line. So this type of graph is known as your linear graph. Whenever it is making a straight line, a line graph which is whole unbroken line, it is known as your linear graph. So whenever we are taking any two quantities which are in direct variation, always the graph will be your linear graph only. Now how to solve the questions based on these type of graphs? How much distance did the car cover during the period 7:30 a.m. to 8 a.m.? 7:30 a.m. to 8 a.m. the distance traveled we have to find. So see, this is your 7 a.m. and this is your 8 a.m. So 7:30 a.m. will be in between these two. 7 and 8 a.m. exactly in between these two, it will be your 7:30 a.m. So when we'll be moving upward from 7:30 a.m. like this, wheresoever it is intersecting your line, linear graph, from this point we will be making a horizontal line like this. So this point will be in between your 80 and 120, that is your 100. This point is your 100 point. Now 8 a.m. 8 a.m. already we have made a graph. At 8 a.m. it was 120. So 8 a.m. we have taken a vertical line like this, and the point where it is intersecting your linear graph, we will be making a horizontal line. like this. So this point is your 100, this point is your 120, and distance traveled between your 730 and 8 will be your from 100 to 120. The car has traveled, the vehicle has traveled distance of from 100 kilometer to 120 kilometer. So distance traveled is 120 minus 100, that is your 20 kilometer distance is traveled from 7:30 to 8 a.m. This is how we can find it out. Now the next question is, what was the time when the car covered a distance of 100 kilometer since it is started? Now see, this is a 80, this is 120, exactly in between will be a 100 kilometer. So from 100 kilometer, we will be making a horizontal line. This is already we have made. We will be making a horizontal line at 100 kilometer. The point where it will be intersecting your linear graph, we will be making a vertical line from here. The point where it is intersecting your x-axis, this is the point where it will be intersecting your x-axis. This is exactly in between your 7 and 8 a.m. So this point is your 7:30 a.m. So this is how, by making your horizontal lines and the vertical lines, we can find the answer. So it must be clear to you what is linear graph, how to plot the line graph for one condition, for another condition, when two things are given to us, when one thing is given to us, and how to plot your linear graph. That is how to find, how we can say that the graph is a linear graph. Whenever it is a straight line, unbroken straight line, we say it to be a linear graph. Or when the two quantities are in direct variation, we say that the graph will be on linear graph. This is all from this chapter. Soon we'll be coming with the more videos of other chapters of class 8 maths curriculum. Hope it is clear to you. Thank you.